there is almost never enough accuracy in time. Since the first clocks appeared, we constantly improve their accuracy, and we always find out reasons to go on and to get new applications and new technologies coming out as a result.
NIST F4 is a cesium fountain clock. It's what we call a primary frequency standard. And what that means is it's supposed to be a machine that allows us to realize what we call the definition of the second.
It makes sure that the time everywhere ticks at the same rate. And so when we say now this event that happened exactly the same official time here and everywhere else in the world.
A clock that's really keeping track of time is not allowed to turn off. If your clock ever turns off, then you no longer know what time it is when you turn it back on. And with the fountain clocks, we don't usually run them in that way.
NIST F4 is like a very fine instrument used for calibrating other clocks that run all of the time. It won't run continuously like the Ensemble that makes coordinated universal time for NIST.
For example, the hydrogen maser, which is another type of atomic clock, is a real clock. It actually produces a signal that can be counted and one can define time with it.
If you want to know if your piano is in tune, you pick a tuning fork off the shelf and you ring it. But you don't need to use the tuning fork all the time. You only need to use it when you want to check if your instrument is in tune. And it's a similar thing with the clocks that run all the time, that make up the NIST timescale. They have to run and be counted continuously, but we only have to probe them with the fountains intermittently because the clocks are so good that we don't need to check them all of the time. By the time that we started working with the current NIST Fountain Ensemble, it was clear that an upgrade would be very helpful in realizing and maintaining the performance of these primary frequency standards for the next few decades.
Vladi came on, realized that there was a large unexplained systematic frequency shift in NIST F1, and it was kind of a fatal flaw.
It's an instrument that needed a lot of attention and a lot of work before it actually started doing what I wanted it to do.
He had to build it from the inside out, rebuild the whole thing. NIST F4 is among about 20 primary and secondary frequency standards around the world that can perform these measurements. It's at the very top of the, so to speak, hierarchy or food chain.
So at some point in the next few decades, there's going to be a handoff where instead of the second being based on the properties of the cesium atom, it's going to be based on some other atomic properties of different atoms. As part of that push, we need state-of-the-art cesium primary standards in order to be able to pave the way to the future and the improved definition of the second.